Hey, good morning. Today is June 8th, 2018. My name is Jeff Fritz, and welcome back to my live stream. Um, and it's Friday. That means it's F Sharp Friday. I need an F Sharp Friday sound effect. Something to bring the appropriate tone for F Sharp Friday because I think this is a great day of the week that we can spend time learning a programming language that I don't normally use, right? Kind of expanding my knowledge, right? And growing as a developer, learning things that I don't normally use, and right, getting involved in growing, right? And that's really what this is all about: is growing, learning, and doing new things. Good to see a lot of folks there in the chat room. John Galloway is here. Good morning, John. Bright and early over there. Maker Blaker, aspiring DevOps guru. Jason Lautzenheiser is here. All right. That console right line. Good morning. Nicely done, Bruno. Cryptrix and Welsh Ronaldo. Hey, good to see everybody. Got to hit the coffee. All right. Let's see. What music are we going to play in the background here today? Let's play. I'm going to play Red is the name of this song that we're going to play. This is a song from our friend Carl Franklin, who, of course, wrote this great album called Music to Code By. I haven't been to the website in a while, so let's make sure we show that. And we'll just have this playing in the background, getting us in the groove so that we are getting focused on what we're working on. So there you go, Music to Code By. Music that's scientifically engineered to get you focused, focused, and it's actually a Pomodoro long, 25 minutes long. If you're familiar with the Pomodoro technique, you work all through the song. When the song's over, take a 5-minute break. Unless, of course, you're streaming, in which case, go to the chat room and see what's going on. So check it out, Music to Code By, and you can download 13 tracks for just a couple bucks. I mean, 13 songs for that much that are each a half hour long. That's a lot of music. But the other music to flowby.com. The other one that he has now is an app called Music to Flow By that has all the songs, and you can subscribe and you get everything for a low subscription fee each month, and it's available in the App Store and the Google Play Store. So check it out. Really cool stuff, and it's this music that you'll hear playing in the background. All right. Next up, I want to be sure to thank our friends at the MS Dev Show for sponsoring the hat that we're going to be wearing today. All through the show, you'll see me wearing the MS Dev Show hat. I want to thank Carl and Jason over there for sending over a hat and asking me to give them a shout out here on my stream today. I'm more than happy to sponsor and show some love for other shows out there. So check out MS Dev Show. Great topics for Microsoft developers. You can get them on iTunes, Stitcher. Check out their YouTube. They've got videos out there that you can watch and learn more about what's going on in the world of Microsoft development. So it was great. I got to meet up with Carl and Jason at Build this year. Great guys. I encourage you to check out their show. All right, so MS Dev Show. We did the sponsorship. We did a couple other. We talked about the music. We showed the website for Music to Flow By. I think we're about ready to get back into our code. Let's see. Print FN hello. All right, there we go. Good morning. Let's see. Is that Dunsheimer fan? Good morning. Dev Chatter's now hosting us. Thank you, Dev Chatter, for the host. What else do we have going on here? Borta and Sherry Uman, new followers out there, and a couple of... No, we had those subscribers last time. All right. Now, what's Noisely? Noisely? What is that? noisli.com. Nope, that's not how you spell that. That's not how you spell that. Noisely, improve focus and boost productivity. Makes different sounds. Okay, so this is a bit of white noise. Not quite music, but that's kind of cool. All right. I like the music because it gets me in the groove. So You used to use noisily, Maker Blaker says. Okay. So it's interesting. Just a quick update. Some of our friends on the F# team, they caught up with us a little bit last week when we started our first F# Friday. And of course, you can catch all these videos over there on YouTube, on my channel, which is youtube.com/C#Fritz. But they saw some of the questions that we were having going through the tour of F# here on the Microsoft Docs site. And they actually changed the tour a little bit based on our feedback. So that's interesting. I'm thrilled that they took our feedback so quickly and made an adjustment like that. So, but we're going to spend some time here for about the next 2 hours going through the tutorial here, maybe writing a little bit of sample code as we get through it. But the idea is we're going to learn a little F# together. Cryptrix says, so at docs.microsoft.com, F# search finds nothing, and F# is not in the more dropdown. Who do we need to talk to fix? Let's back up a little bit here and let's take a look at what Cryptrix is talking about. Let's hide that. I don't need to see this. Thank you. All right. So I'm going to go to docsmicrosoft.com. So you're doing a search for F#, which, okay, I get it. What happens if we do a search for C#? Okay, so it does come up with the tour and some other things. What I'm doing, Cryptrix, and we can certainly talk to our friends on the Docs team about what's going on with this. What I'm doing is I'm just going down here in the directory, and there's F# right there. Click it. And I'm in to the F# guide. And starting here. So what I'm going to do, I have a notepad up over here in another window. I always keep a notepad open on another screen or on another desktop. I'm going to take down your note here, Cryptrix. docsmicrosoft.com. Search for F# yields no results. C# search returns, at the very least, the C# guide and a bunch and other articles. You're logging a bug now, John Galloway says. Terrific. All right, then I don't need to. I'm going to logged by John. All right, cool. Thank you, John. Look at that. I got some friends helping in the friends helping in the chat room. And actually, I need to do something here. Let's take care of this. Should have done that a while ago. I'm going to throw a sword over to John so he can help moderate. Anybody else here? There were some other folks that I wanted to make sure got a moderator while we're here. I don't see them off the top of my head. All right, that's fine. Good morning, Evandro. I don't like RAID 5. What did Joban say? It's not PowerShell Friday. No. Cryptrix says, respect to the new Microsoft. Good work. Oh, thank you. It's important to me that we be, we Microsoft, be what I like to call a good internet citizen. I think what you've seen from our leadership is that we're much more customer focused. That's something that I like to stress is in my interaction with you is I am very customer focused. I want to make sure that whatever I'm working on, whether it's this show or an event, we're delivering value that you appreciate, that you need, and that we're responsive to you. There's a lot of customers out there, so we can't do everything everybody wants because there's sometimes conflicting wants or needs. But we're going to do our best to accommodate the best of what everybody needs. RAID 5 saved my data. Cool. All right. I still use it while it's rebuilding. If my controller supported it, I would select RAID 6. I recommend the book over at Syncfusion F# IMO. Their Succinctly series are free and really good. Let's pop that open real quick. So Syncfusion, of course, they're a vendor that builds, right? They build controls. different features. Succinctly series on the go. Is there an F# one here? So these are ebooks. ASP.NET Webhooks, Xamarin Forms, Java, Async Programming. 130. Is there an F# book? Hey, there we go, by Robert Pickering. So that might be cool to check out. And completely free. All right. Oh, it might not be part of the URL. Yeah, it wasn't. So you can download a PDF and then learn F# if you'd like over there. Very cool. Of course, and we shared a link last time to some of our friends' books that have written, like Isaac. Can I give a shout out to Germany? Absolutely. What time is it there? It is... You are 6 hours up. Guten Nachmittag, Deutschland. I'll be out there in 3 weeks for Developer Week Germany in Nuremberg. Very much looking forward to that. There you go, 16:11. All right, I got my time right. Central European time. All right. And I hope I didn't butcher my German terribly there. Let me know. See now. Oh, I'm all right. I am my reading German. I am hoping to rock F# a bit better this week. I agree, S&B. I completely agree. So thank you very much, all the folks that are tuning in. We're trying to grow the number of viewers that we have here joining us each week, and I'm looking at doing some giveaways, looking at doing some stickers, some things to show your support, to kind of grow what we're doing here, make it more interesting. I have a number of guests lined up. I think this might be the last F# Friday that we do where it's just me going through tutorials. After last week, I had a number of folks say, "Oh, I'd love to pair program with you doing an F# project or two." So I think we're going to start talking about that. Great German. Oh, thank you. Danke. My Bulgarian was terrible when I was working with Bulgarian team. So, all right, I'm about halfway through that book. Since yesterday, it flows really well for someone who already programs. Awesome. Oh, you know what I'm going to do? I'm going to do one more here. You know what, Smab? You've been doing a great job for us here. I want to make sure, let me throw you a sword as well. Thank you so much for your participation for the past few months, helping us out here on the channel. So, I want to recognize you with a sword here as well. All right. Let's get back into the tutorial here. Now, to recap, I'm starting with the F# guide here, not the F# guide, with the tour of F#. Mosteller, thank you for the follow. I appreciate that. Hey, Justin, good to see you. Mosteller, I look forward to seeing you in the chat room, asking questions. We're more than happy to help out, but we're learning F# together here today. So I clicked through from the docs just to make sure you remember how we got here, right? So I went to docs.microsoft.com. Of course, this is my English American version. And I clicked through to F#. And we're going to be doing I believe it's the tour of F# is where we are. And from last week, we had come down, and I believe we were about to get into pattern matching. I had just finished up record and discriminated union types. Knights of Fritz. Yes, Bruno. Absolutely. All right, so records are an aggregate of these. Oh, gosh. Derek's. Thank you for the follow. And I've been keeping Steve a little bit quieter out there. Are you able to hear him all right in the chat room? I want to make sure that Steve's funny when he pops up, but he's not annoying. We save that now for when someone subscribes and we have Steve and Bill join us when somebody clicks the subscribe button. Let me think. There was something else I wanted to do. Yeah, so and I want to make sure I call out up at the top of the screen, we have our GitHub contributors score ticker. And right now there's only 2 projects on there, Stream Tools and Core Wiki. I got a great suggestion for a project from Philip Carter, who's the language design lead for F#. I think that's a project that will start next week. I'm not sure if Philip will be the guest or somebody else, but I think we'll start that, and you'll see an entry for an F# project up top there as well, because I'm really enjoying learning this language with you, and I think we need to start on a real project here. So I'm about halfway through this. I think we'll probably get through the rest of this, write some practice code here today, and then next week we'll start a real project. And get our hands dirty, get our feet wet, make a mess of things. You know how it is. All right. I'm keeping an eye on my frames per second to make sure that I'm rendering and delivering properly, and it looks really well. If you already know C#, the fastest way to learn F# is probably to go through the docs cover to cover. TLDR, I'm going to agree to disagree on that. Reading the docs works for some people. More power to them. I'm one of those people that could read the docs cover to cover. But other folks like a little bit of a tutorial. They like an instructor, somebody who can answer questions along the way. Tutorial videos, events. There was the F# Conf a few months ago on Channel 9. That was really good, a really good place for folks to learn. And I think S&B makes a good point here. A real project helps to crystallize the concepts. So reading through the docs is pretty good for some folks. I'm one of these people who also has a real-world project next to him, so I can write some code along the way. And you're going to see a little bit of that from me here, where I'll go through and look at some of this, copy it into Visual Studio Code, execute a little bit, and come back. So I do a little bit of a couple different things. There you go. ShiftKid is a more visual learner. So the best way to learn is to find an interesting project and get stuck in. That's a good one, 7#9. I've actually heard some folks, they have the same application that they just rebuild each time when they're learning a new language or a new framework. So they've got it built in ASP.NET and Node.js and PHP and Rails, and they just keep going around. Hey, I'm Tony Stark. Welcome. All right, let's pick back up here. So I think we went through records and discriminated unions. And I think, we did this cards sample last time, and you can pick up that video out there on the YouTube channel if you'd like. F# as a functional language requires you to change your brain around, otherwise you'll just end up trying to write F# procedurally. Amen. That OCaml looks weird. Okay, I need to figure out a widget so I can have a first-time avatar, cool avatar of the day. Nice nick there, that OCaml. That's well done. Hello, good to see you. Okay, so a discriminated union is a little bit like a class like we have in C#, where you have, but we call it a module in F#, okay? And you have different types hanging in here with members, and it looks like some functions hanging off of it as well here. Very cool, SMAB. A small program you've written in at least 6 languages so far. All right. You can use discriminated unions as single-case discriminated unions to help with domain modeling over primitive types. Oftentimes, strings and other primitive types are used to represent something and are thus given a particular meaning. Okay, I need to see an example of that. However, using only the primitive representation of the data can result in mistakenly assigning an incorrect value. Let me read that again. Using only the primitive representation of the data can result in mistakenly assigning an incorrect value. I don't understand what that means. Maybe we'll figure it out. Representing each type of information as a distinct single-case union can enforce correctness in the scenario. So, a little bit of background about me. I'm not a computer science person. I'm more of a business developer. I spend a lot of time building business value into applications. So, I'm not familiar with a little bit of this. Let's see what we can learn here. Single-type discriminated unions are often used for domain modeling. Okay, that I understand. This can buy you extra type safety over primitive types such as strings and ints. Makes sense. Okay, so I'm thinking like an account or a product that I might have in a shopping cart application. This is like an ADA subtype. Temperature and speed can both be integer but not mixed in an expression. Ah, okay. I think F# for fun and profit is a better way to learn F# as a C# developer. Alright. We call this primitive obsession. Imagine a toggle type. Instead of is toggled as a bool, use a toggle equals on or off. Okay. Brave Cobra, I never found F# to be readable. And that's the way I felt for a long time, and that's why I want to do this series on Fridays, so that it does become readable to me. That's exactly why I'm doing this, Brave Cobra. I want to understand this better. So I like what Chusk is saying there, is that we're almost going to, dare I say, alias existing types to kind of force something that's a little bit more discrete. So, why is that different to an enum? Good question, Cryptrix. That feels very much like an enum. I'm going to continue here. Single-case discriminated unions cannot be implicitly converted to or from the type they wrap. For example, a function which takes an address cannot accept a string as that input. I think we may have touched this briefly last time, and this is where I ended. So type address equals address of string. So this looks like it's aliasing, right? It's doing that alias to say this is a string, but it's something. Let's say Dark Tower Builder says if you can summarize the mission of F# in one sentence, what will it be? I don't know. F# gives folks a functional way to program and use the .NET base class library, the .NET tools, and build applications, whether it's with Xamarin or with ASP.NET and .NET in a functional manner, if that's what they want to use. Python-like Lua-ish language for .NET. That might work. Enums are like aliases for ints, but discriminated unions have definitive values, so you have a limited set of possible values, with optional payload in each case. Yes, okay, I'm seeing that. You can easily instantiate a single-case discriminated union as follows. So let address, so we're declaring a variable called address with a lowercase a, equals address. We're defining this string is an address, versus a name with that string in quotes. Makes sense. Let SSN equals SSN of int. Okay? When you need the value, you can unwrap the underlying value with a simple function. Okay, so here, right, this looks like in C# an explicit cast is what it looks like. So we're taking in address A, right? Something that's of address type A, and we're going to output A, right? So we've declared this function unwrap address. Okay. And the same things here. So printing single-case discriminated unions is simple with unwrapping functions. Okay. So rewinding to last time, we learned a little bit about these pipe operators. So print, and then right we've got this formatting, and the formatting is positional. So we're going to take the address, which is 111 Alf Way. We're going to pipe the value, right? That's what this is, pipes the value, through the unwrap address function. So this becomes the argument going into it, which is going to output just the string. And that will be dropped in here. Got it. We're going to do the same thing with the name. We're going to take the name object Alf, route it through, pipe the value through the unwrap name function here, which will output just the string Alf and drop it in there. Same thing with the social security number. Got it. That makes sense to me. Okay. Yeah, pattern matching I think is up next, right? Looking at the table of contents here, we're going to go into pattern matching next. You get the underlying value in a single case discriminated union. You must explicitly unwrap it. So you can't do the implicit conversions like we have in C#. Okay, makes sense. Discriminated unions also support recursive definitions. Ooh, okay. This represents a binary search tree, with one case being the empty tree and the other being a node with a value and two subtrees. Okay, so type binary search tree, right? I'm assuming that's what BST is standing for. So we're defining a new discriminated union type, just like we did up here, except this one's a little bit more complex. And I was told that the exclamation point, the apostrophe, not exclamation point, single quote T is like a generic notation. Let me zoom in here a little bit. I realize that's small. How's that? Is that better? I know at that resolution. So that's a generic parameter. Oh, thank you. Okay. So one is empty, the other being a node with a value and two subtrees. Okay, so node of value. So we haven't seen this type of markup yet. This type of, not markup's the wrong word, syntax yet. So let me try and parse this apart. So node of value. Okay, so generic type T. Now, do I always need the single quote, or can I just put T? More on that later, I guess. Okay, value T, star left. Okay, so right. So binary search tree has a value and a left and a right. It's a tuple name of 3 named items. Single quote is a must. Okay. So this is a tuple, right? So 0, 1, and 2 positions. So the value, the left value, the right value, and the left and the right are themselves not just that generic type, but another search tree. So that makes sense. Okay, I get it. Okay, so this is saying that it's a node, and this is how we're defining it. Okay, and then I can see it being tinkered with down here. Check if an item exists in the binary search tree. Searches recursively using pattern matching, and we're going to see pattern matching next. Returns true if it exists, otherwise false. All right, so let rec exist. So we've defined a record type. We're returning a record type called exists. Item BST. I'm kind of lost on what that is. Or is this the record type is these 3? Match BST with, if it's, okay, so if the binary search tree is empty, return false. Rec and a let binding is recursive. Oh, that's right. Okay. Node X, left, right. All right. So if item, so the item being passed in equals X. So if the value in the tree matches, then return true. Okay. Else if the item is less than X. How do we know it's less? That less than comparison looks funny. What if it's a string in my binary search tree? Then exists item left. So then it's going to pass this. J plus CHH, welcome. Thank you for the follow. I look forward to seeing you in the chat room. Yep, I forgot the recursive notation. Okay. If it's less than x, then, right, we're going to do the exact same thing, and we're going to pass down the left tree. Otherwise, we're going to go down the right tree. Right, so binary search tree, right, lets you have this, it's a computer science, not a computer science. It's a programming model that allows you to do a search very quickly through a collection. Why else? Elif is else if in F sharp. That's the notation. Where is it stated that type T needs to be ordered? When is the check for equals and less than done? Right. Inserts an item in the binary search tree. Okay. The inherited generic type of the search item will require a comparable type. Yeah, that's what I'm seeing. Yes, it is less than. In this comparison is what I'm understanding. Inserts an item in the binary search tree, finds the place to insert recursively using pattern matching, then inserts a new node. If the item is already present, doesn't insert anything. So insert item, so recursive, this is a recursive function called insert. It takes two parameters, item, and then the binary search tree. We're going to match the binary search tree with, well, if it's empty, we're going to create a new node with item empty, empty. So no child trees to search through. If item equals X, then node. So it found it, right? So if the item that passed in is equal to the value in the node, right? So this is doing the search, right? It's saying, okay, so for each, right, match the node in the tree. We're going to capture X, left, and right as the values coming out of that tuple. And so if the item is less than X, then we're going to return a node with the value X, which is the current item that's in there. And we're going to insert into the left and return the right. Okay. Otherwise, we're going to insert onto the right side. I think that makes sense. I agree a little bit S and B, and we'll figure that out in just a minute. Can't you put another if expression inside the else part? Yeah. I think you could. But why? Because discriminated unions allow you to represent the recursive structure of the tree in the data type, operating on this recursive structure is straightforward and guarantees correctness. It is also supported in pattern matching as shown below. Discriminated unions can also be represented as structs via the struct attribute, right? And struct is a value type in .NET, right? It gets allocated on the stack. Garbage collection takes care of it rather quickly. However, there are two important things to know when doing this. A struct, a discriminated union, cannot be recursively defined. That's probably okay. All right. A struct discriminated union must have names for each of its cases. Cases. That's a new noun that I haven't seen yet. Value types are not GC. There you go. That's what I meant. However, there are... okay, so type shape. Okay, so this is a struct type. We're forcing it as a struct type, so it's not allocated on the heap. Circle of radius, float. Okay, so we're aliasing to a float. Square of side, float. Okay, so this is a... Okay. And then triangle of height, and it's a tuple. Height and width, each one is a float. Okay. Failure to follow the above will result in a compilation error. I think that may go towards what Cryptrix was saying. Pattern matching. All right, here's something that we just saw. Case equals one branch of a discriminated union. Okay, that makes a little bit more sense. Is the F-sharp language feature which enables correctness for operating on F-sharp types. Right, this is something we just got in C-sharp, but pattern matching has been available in F-sharp for a long time. How we doing? Good. Yeah, all right. In the above samples, you probably noticed a bit of match X with syntax. This construct allows the compiler, which can understand the shape of data types, to force you to account for all possible cases when using a data type through what is known as exhaustive pattern matching. What's the difference between exhaustive pattern matching and regular pattern matching? This is incredibly powerful for correctness and can be cleverly used to lift what would normally be a runtime concern into compile time. Okay. All right, let's see. So we've defined a type, a record type, called person, that has two properties. First, which is a string, last, which is a string. Okay. A discriminated union of three different kinds of employees. So we have an employee that is an engineer of engineer, which is a person. So we have engineer, which is aliased to person. We have manager, which is aliased to the tuple of person and a reports object, which is a list of generic type employee. So this is recursively referencing itself. That's pretty cool right there. Right? Because I have a manager who is an employee type, is a person with a list of employees. Exhaustive means you need to handle all the possible cases, or else you get a warning at runtime. If you tried to match a value that isn't handled in one of your functions, you'll get a match exception. Okay. Executive is a person. Okay, so now we have another tuple here. Person with a list of reports and has an assistant. La-dee-da. An executive has an assistant. Hoo-hoo! Look at that. Aren't they fancy? I know. All right. Count everyone underneath the employee in the management hierarchy. Count everyone underneath the employee in the management hierarchy. Okay, so this is a function. It's a recursive function. I'm moving things around on the desk here. Let's see if we can move that there. So I realized that my Stream Deck was way over here, and it's not right under where I'm looking. Looking at employee, I am beginning to see the power of this. I agree, S&B. ShiftKit says high society. I know. They're rolling in it. All right. There's even an exception. How awesome is that? Well, hang on. You're getting ahead of me. All right. Does a compile time check that the branches are exhaustive? That's the important thing right there, is I'm getting that check at compile time. Let me finish reading through the sample here. Count everyone underneath the employee in the management hierarchy. Okay, so this is a recursive function. And it's interesting that I still find this interesting that I have to declare that the function is recursive, where a method in C# or VB, I don't have to, right? It just does it. And good luck. Here, right, it's actually doing a little bit of a check. I'm thinking you need a whiteboard to help your head around this as well. I don't know. The tick character in generic definitions was bugging me, so I looked it up. Okay. Isn't SRTP? What's SRTP? Strict runtime policy? So, real-time programmers? Save Statically resolved type parameters. Thank you, Godfiend. I don't know. Let me get back to the thing. Okay, let me get back to this. Count everyone underneath. All right, so I'm trying to figure this out. Count reports. So we're going to take in an EMP object that is of type employee. Now it's interesting to me that this method, this function, is using parentheses to receive the input parameter, right? Where up here, we didn't use parentheses. Okay, equals 1 plus match the employee with. So 1, we're counting the employee that was passed in. And if the employee is an engineer, now, where do ID come from? I don't see ID anywhere. So, yeah, what's that? But it match with, if it is an engineer, then we're going to return 0, right? This is the effective yield. Sixers responsibly trust the process. There you go, Popsicle. Ha-ha! All right, we figured that out. I'm going to trust Chusk on this one. In Godfiend. Parentheses are needed when you set the parameter type, like switch case when. Okay. Backtick are required to differentiate from statically resolved type parameters. All right. ID is the person record in the engineer. Okay. Okay. So we're using so we're matching with this type, and the parentheses are giving us a pointer to the person record in the engineer. Okay. For feedback for the sample, I might have called this lowercase person. Manager ID report. So the manager, okay, now this makes a little bit more sense. This is the tuple person and reports. That makes a little bit more sense to me. Okay. If it does match that manager type, we're going to yield, and we're going to take the reports object, right, which is that list of employees, and we're going to pipe it into that. We're going to pipe the value reports list.sumBy, okay, count reports, which is this function. So we're going to pump back into it the list of employees. Okay, so SumBy, we're going to execute count reports, right? SumBy, I'm assuming, because I haven't seen, and we may have seen the syntax up higher, it is effectively a for each and just adds to itself. Okay, so executive, an assistant as an employee, which is another. Okay, so an executive ID reports assistant, so person reports assistant, so that matches here. Cool. We're going to take the reports, we're going to pipe it through list.sumBy count reports so that we count all of those folks, plus count the reports on the assistant. Okay, cool. It takes ID, reports, and assistant just like the members. Yeah. Giving you access to the fields in the constructor. Person had first and last, not ID. That's where I'm just a little bit confused there, Cryptrix. And for the purpose of the tutorial, knowing that ID is the person inside of it, it might have been clearer to call this person, or to put a little bit of a comment over here that says ID is the person. But now that the folks in the chat room have explained that makes it a lot easier for me to understand. Find all managers, executives named Dave. Hi, Dave. Good to see you, Dave. How are things this weekend, Dave? Are you going boating this weekend, Dave? Who do not have any reports. This uses the function shorthand. This uses the function shorthand to as a lambda expression. I think that should be just as a lambda, but okay. Find Dave with open position. Maybe find Dave as open as individual contributor, right? I know some organizations use that term, right? We use that term at Microsoft. So find Dave with open position. Okay, so we're going to take in a list of employees. I'm going to start looking for Dave. Hey, Dave, how's it going? Dave. It's right up there with Skippy. Skippy's the name I generically use to refer to somebody in the accounting department. Hey, Skippy, how's it going? It's almost April 15th. You kind of busy? All right, so we're going to take that list of employees. We're going to value pipe it into another list because we're going to output all the Daves. Hey, Dave. And we're going to filter with another function. So is this an anonymous function? This uses function shorthand. Oh, as a lambda expression. Okay. That's what we're trying to show here. Pay attention, Jeff. Pay attention. Pay attention. I got it, Shia. All right. So manager first equals Dave. Okay, so pattern matching. So the pattern it's saying is pipe into manager if the first name is Dave, and then they don't have any reports, right? Because the second part of manager is reports, and that's a list of employee. Well, if it's double square bracket, it's an empty list. Then we're going to yield true, which will, I'm assuming for that list filter, return the manager object. Hey, Godfiend, thanks so much for the follow. I appreciate that. Steve, you've been a little busy here this morning. Getting a little sweaty there. We've had 4 follows already. Think we might be able to make it 5? Steve? We should change this to first is Steve, because we like Steve here. Why does it start from a pipe? Is it a discriminated union? Yes, these are discriminated unions, right? The employee here. The function shorthand often causes confusion to people starting with F#. Okay. Okay. It's like a function instead and gets its parameter there. Yeah, I'm looking at this like a lambda, right? Function, in my mind as a C# developer, I'm looking at function, and this is the left side, right? In my crazy stupid head. I'm just going to put a C# file out here, right? Public class, Jeff. Public void do stuff. Right, I'm looking at this as string s equals something dot let's do where and right x dot whatever, I don't know, right? I'm looking at in my C# head, I'm looking at where'd it go? It scrolled on me here. So I'm seeing list.filter, and I'm thinking of that like this. And I see the word function and pipe here, and I'm taking that to be equivalent to this. Howdy, Statute K 1992. An anonymous function with an anonymous argument. Yes. Yes. Because this is a pattern match. All right. It scrolled again on me. Here we go. That's where we were. All right. So if it's an executive with first name Dave and I don't care right? The underscore, yeah, wildcard pattern matches anything. We're dumping the results. Ignore what this is, but we need to make sure that it's that empty list of reports because they're an individual contributor, and we're going to return true. And if it's not a manager or an executive, wildcard, if it's anything else, yield return false. So it won't put that employee into the returned list. That makes sense to me. It allows you to drop the parentheses. If you were using a switch statement in where func, then yeah. All right. Okay, you can also use the shorthand function construct for pattern matching, which is useful when you're writing functions which make use of a partial application. Partial application. Gonna have to look into that later. Okay, if you were to use this, yeah, all right. All right. Let me know, am I going too fast? Am I going not fast enough? So open system. I don't know what that is yet. You can also use the shorthand function construct for pattern matching, which is useful when you're writing functions which make use of partial application. All right, so here's that double pipe again, which, okay, let's let private parse helper f. So we're defining a function called parse helper that takes in an argument of f. S&B, you can hit the videos and go back to that. For anyone that knows, is the function versus the match syntax basically point free? Open in F# equals using in C#. Thank you. That makes sense to me. So I'm using the system namespace. Okay. That makes a lot of sense to me. All right, so we're declaring a private function called parseHelper that takes in an argument of f, and f we're going to all right. So the double greater than was we're going to bolt it right onto this function. True item, some item, false. Okay, this is a little confusing. True, so if it matches true and some item, the tuple of true and some item, then yield. What is sum here? And then item. I'm not sure what sum is. Otherwise return false, and otherwise if it matches false in the wild card. Okay, so I'm clearly passing a tuple in here. Okay. I think we're going to have to come back to this. Let parse datetime offset equal parse helper datetime offset dot try parse. I'm not sure what. Okay. All right. Parse helper is this function up here. You might have better luck after seeing how it's used. Yeah, I think you're right. The option type can either be a sum or a none. Very similar to a nullable. Yeah, that's the syntax that I'm I'm understanding. Chusky? All right, wow, 87 folks here joining us today. Thank you everybody for tuning in. Option is a built-in discriminated union. Oh. Okay. So parse datetime offset is a function that's going to call parse helper on datetime offset try parse. So we're familiar with this. This is in the base class library. It is hanging off of system. Okay, let result equal parse datetime offset 1970 0101, right? So the earliest date that we normally work with. Match result, right? That's the Unix epoch. Okay, so the match result. Okay, so we're going to go through. with and then pipe. So we're passing the result directly in here. Sum DTO. Now what's DTO? Print fn it parsed. Okay, so if it... So parse datetime offset, we're going to do datetime offset parse. So we're bolting this onto parse helper for this. So this is going to do, yeah, data transfer object, I got it. Where did it come from? I don't see this declared anywhere. And without highlighting to show they are something special. Datetime offset. Dave trolls the office. I don't know. We'll figure that out. Hang on. And I notice my focus on the camera is playing games here. It should not be focusing. I don't want you to be doing focus things here while we're working. Stop it. Stay focused. Right, just like Shia says. See? See, camera? I'm watching you. I think it's datetime offset based on what this is trying to do. So we're bolting this function onto this parse helper. So if this returns... Okay, so try parse returns two things, right? It returns whether it was successful, and it returns an output that is the datetime offset. So if this returns true as the first argument, right? Because it returns, right? It returns two things. If it returns true, it's going to return sum and then whatever the item is, which will be in this case the datetime offset. So this is declaring a variable called DTO for datetime offset. So I think S&B was right there. Points to S&B on that. There you go. Enjoy your coins. I don't know where you can use them. It parsed. Okay, so we're just going to print it parsed. But if it returned false, we're going to return none up here. So print. All right, that makes sense to me now, because I'm effectively doing something with the output on this, because none is a type. Right. In this example, since you don't use DTO, you can actually make that line sum underbar. Yes. Now, Godfiend, that makes sense, because it isn't used, or if we actually called this datetime offset or output datetime offset. So I get that. All right. Cool. You're making the null concept explicit with none. Similar to the nothing concept in VB, I'm assuming. All right. Let's define some more functions which parse with the helper function. So let parseInt equal parseHelper, int32 try parse helper, double try parse. All right, makes sense. Something you may have noticed is the use of the underscore underbar pattern. This is known as the wildcard pattern, which is a way of saying I don't care. Okay. Although convenient, you can accidentally bypass exhaustive pattern matching and no longer benefit from compile time enforcements if you aren't careful in using the underscore. It is best used when you don't care about certain pieces of a decomposed type when pattern matching. Right. It is best used when you don't care, blah, blah, blah. Or the final clause when you have enumerated all meaningful cases in pattern matching expression. Cool. That makes sense. It's the default at the bottom of your switch case statement in C#. Yeah, hey, look at that case segment. We're on the same page. Awesome. Active patterns are another powerful construct to use with pattern matching. They allow you to partition input data into custom forms, decomposing them at the pattern match call site. they can be parameterized, thus allowing to define the partition as a function. Expanding the previous example to support active patterns looks something like this. Uh-oh. All right, now we're getting a little crazy with the vertical pipes. They allow you to partition input data into custom forms. Whew. Active patterns hurt my head, says Godfiend. You can forget to go back and add some explicit case later. It'll fall through to underscore. So a function that only cases about employee might be let fe equals match e with underbar employee person. And then at the very end, pipe underbar printfn don't care. That makes sense. I get errors on compilation. Line 5, parse int. So I think we're kind of bolting these two samples together here. Let's actually do that. I'm going to copy this and go over to Visual Studio Code. Let's get rid of that C# example because we don't care about C# because it's F# Friday. All right. Now, why are those? All right, whatever. And then let's bolt on these active patterns here. All right. I copied over the same thing twice. There we go. All right. All right, so let int. Now, I'm not familiar with that. Ionide will display the types above them. Okay, cool. Bolting worked. Is that a technical term? Yes. Right, we're soldering. We're physically connecting these together. There was a horror movie about this with people, and not going there. All right, so let int. So I'm confused what that notation means. Equals parse int. Let double parse double date parse date time offset. Here's how. Replace code lens, editor code lens false. It should. I'm not sure why it's not popping up. Yeah, it's not showing. If I save, is it going to show? No, it's not showing. Banana clips define the beginning and end of the active pattern. Oh, these are called banana clips? Really? Okay. Oh, wait a sec. Hang on. Right, let's do this. No, I want to do... Where is it? I want to toggle... I want to toggle the split bar. Hang on. So we did the matching, the pattern matching here with pipe and then some condition. Let's do this a little bit more, right? So we did the pattern match there. Is this saying... We're going to do... I'm going to use banana clips, 7#9. Sounds good to me. Is this doing the same pattern match, but instead, right, we're defining the start of the pattern match with a beginning banana clip and an ending banana clip. And then in the middle we have int, match on the int. Otherwise, right, the underbar, I don't care. So instead of doing, right, so parse int is parse helper this. So the banana clip symbols are referred to as banana clips, and the function created by this type of let binding is called an active recognizer. Okay. So we have this syntax, and we're saying equals parse int. All right, let's see how that's used here. No, I'm trying to. I don't. No. I want this one bigger. No, don't. Well, that's annoying. All right, so let's see how this works. Let print parse result equals function. Okay, so we're defining a function. Print parse result. So if it matches on the integer type of x, on an integer, capture it, put the value in x, and we're going to print print the digits with x. If it's a double, print the float of x. If it's a date, we're going to yield that date d. And we're going to call date.toString and pipe that string out. All right. If it's a time span, did we have parse? Oh, okay. If it's a time span, we're going to print the string with a toString there. Okay. And otherwise, if it doesn't match any of those that we know how to parse, nothing was parsable. Fritz of C#. I've never heard that expression, but I have banana clips and I see why they're called that. Yeah. No, that makes sense. I can understand that. Sure. I hope I don't start referring to these as bananas. Two-string bananas? No. All right. Call the printer with some different values to parse. Okay. So hang on. So all right, hang on. I've never heard that expression. All right, since we're using partial active patterns here, the compiler can't give us total matching, so we have to have the default there. I got it. I got that. That makes sense. Right? Right? So this is doing pattern matching based on whatever's passed into print parse result. And what I'm trying to get my head around is this int that int? And how is that different from, okay, that's int 32, but I see double, double, double. That looks all the same to me. So print parse result, and we're passing in the argument 12. So 12 comes into the function, and we're going to match the 12, which we'll do a try parse against parseInt, which will do int 32 try parse, and if it outputs true, we'll return the integer all the way up. This feels completely unnecessary. I'm not understanding why I need this. I don't see the value that adds. Right? Why can't I just, instead of saying int x here, say, well, if I say parse int, right? Parse int returns, right? It prints out a string. Oh, no, wait. No, it doesn't. Hang on. Parse helper, it'll return the value. So, yeah, I'm not quite sure why I need that. If the return to option value is sum, then the partial active pattern is considered matched, and you'll hit that branch. Yeah, but why not just call parseInt directly here? You know what? Let's do it. Jeff parse result equals, and I'm going to do the exact same thing here because I want to understand why I need that, right? Let's just see what happens. Instead of saying that, let's say, if I say parseInt there, right? Right, if I do that, right, parseInt will return, it'll return true, so it'll return some item. So it'll return the item, which will be passed into X. Right? It's a partial active pattern. If matched, it will activate and then decompose the value into the X value. I hear you. But I don't understand why that wouldn't work as well. parseInt is not a pattern, it's an expression. Ah! Okay. That makes sense. Okay. So the banana clips say this is a pattern. Just like this type was a pattern. Okay. That makes sense. So we can't match on... Okay. I'm feeling you now. Nimi, I got it. That makes sense to me now. So we're matching, in pattern matching, we're matching, right? So we have this type employee, which is an engineer or a manager or an executive. And we did the match here that says, well, if this employee is of type engineer, then output this. And then we went further down here in the parse helper, where we're saying, okay, take in that function and pass it in, and if it matches the output true and some item, I still don't understand what sum is, but we're going to yield that item object. So this is a function. This is a method. This is a function. And we've defined these helper functions that bolt on to that parse helper, our standard try parse methods. Okay. Now the banana clips are saying this is a pattern. And this pattern object we'll call parseInt. But I don't see how this pattern is there. So I get what Kyle is saying. Int pipe underbar is a partial active pattern. If it is matched, it will activate and then decompose the value into the X. I get that. I don't see why isn't this here. Because that pattern parseInt, i.e. if you match an int, use parseInt. I get it. Why isn't this just saying match type int? The pattern will match if the function returns some t as opposed to none. Is also a function that you can call. You must keep the parentheses, much like using it is there. Read the document linked at the comments to explain the difference. All right. Okay. Active patterns enable you to define named partitions that subdivide input data so that you can use those names in a pattern matching expression, just as you would for a discriminated union. You can use active patterns to decompose data in a customized manner for each partition. Complete active pattern definitions is let banana clip identifier 1, identifier 2, arguments equals expression. Partial active pattern definition, let identifier, and then I don't care what else, arguments equal expression. Okay, so we didn't have any arguments for this. Int is a pattern introduced and brought into scope by where is that name? I hear what Chusk is saying. That int is a pattern introduced. Great. Where? Right. This. Okay, this isn't declared anywhere else. This is. How is this different from this? Line 27. This is where it's declared. I think you can name it however you like. It doesn't have to be int or double. Okay. All right. So let's back up here. And let's call this, just to make this different, we'll use Dave again. We'll make this Linda. And we'll make this Julie. So then, does this become... Oh. While not completely descriptive of what they are, right? Does that make sense? It is, right? Am I... Start that. Execute. Send the whole thing. Whoa! Alright, hang on. It parsed 12045, 1228. Nothing was parsable. Okay. Int is a pattern introduced. Okay, so hang on. This identifier all right. Yeah, the example being type-based is a bit confusing, especially with recent C# features. No, it's having the names of these things match the types. Okay. So let me read through this now. In the previous syntax, identifiers are names for partitions of the input data that is represented, or in other words, names for subsets of the set of all values of the arguments. Okay, so when we use the banana clips, we're defining a pattern, and the name of that pattern is Bob. That's right, because that's the identifier? I think the recent C# features are only a small subset. Oh yes, they are. Consider the following active pattern with an argument. Okay, so we have a pattern with identifiers even, odd, and it receives an argument of type input. And it's the function if input %2 equals 0, then even, else odd. Okay, so this is a pattern we've declared. And the argument being passed in is input. Okay, so let test number input. So we're defining a function now. Match input with, if it matches even, So it's pulling even out of this pattern. So even and passing in that argument, if %2 equals 0, then even. Well, why not then true? Because we passed in even, I guess. All right. Then even, else odd. Okay. So even is matching that pattern, which passes in the argument of 7 in this case. Okay. We'll get to a bigger subset in C#8. Okay. All right. So this has to match this. And so we're taking input and we're doing the pattern match against, and because this is one of the keywords inside the active pattern we've declared, this triggers the active pattern match, which is this function, which takes in that argument, applies the test, and then outputs this part of the match. One of the named identifiers in the active pattern should be returned by the expression. You're naming the pattern. Oh. Hey, there's Isaac. Whoop. Did I see him? I thought I saw Isaac for a second there. Yep. Where is it? Yeah, there he is up top. Let big, medium, small text string of string.length greater than 20, then big. Ah, okay. Okay. Copy that into your IDE. I actually don't have the chat wired right up here. That makes sense. But parse int returns an int 32, not an int. We're matching a type. Int is an alias. Right, but I changed that, so... Alright. Let's go back to the way this was. Okay. So function int. So int matches the name of this. So this invokes this pattern that says, did it return of type int? Right, because parse int, right, is a parse helper for int 32. Try parse. So it returns F# Friday. That's right, Voxygon. Okay. Okay. I think I get it. I think this sample is a little bit more clearer. Another use of active patterns is to decompose data types in multiple ways, such as when the name underlying data has various possible representations. A color object could be decomposed into an RGB representation. Okay. So system drawing we're going to use. Let me look here. All right, we got about a half an hour. All right, so let the RGB active pattern. So the argument we're going to take in is a call, I guess that's short for color, of type system drawing color, and we're going to decompose into a tuple with R, G, and B component objects from the color. Let HSB, which is hue, saturation, and brightness, we'll take in the color and we'll decompose into this if it matches. Okay. I think the documentation I am using is not very good to learn these concepts from. Well, it's all about feedback, right? The documentation is open source. We can adjust it, as needed. So let print RGB taking in a color. So we're going to match that color with, so if it matches, if it matches the RGB, taking in, now why is it taking in RGB here? It's receiving out. It's decomposing into RGB. So col is being passed into RGB because that's a color, and it's decomposing back into the RG and B values, which are being used as that output. Okay. Yeah. All right. So same thing here. So col, and if it matches the HSB, is of type color. But it could actually match both of them, couldn't it? And then you would get both. Print all col. All right, so we're color string equals col. It's not clear what col is there, but okay. And then color string, print fn. So we're going to output the color string, print RGB, that color. So why isn't this explicitly defined as a system drawing color? Or are we getting, is it inheriting, deciding that? Because this says it has to be a color, and this is saying it has to be a color as well. The strongly typed language person in me is looking at that and saying, I want a type for both of these. In this case, the choice isn't RGB versus HSB. It's based on how you want to view the data. Type inference. Yes, I'm picking that up. All right. The output of the above program is as follows. So there's the RGB. So it matches, right? It matches on both. Print RGB. Okay. Okay. In combination, these two ways of using active patterns enable you to partition and decompose data into just the appropriate form and perform the appropriate computations on the appropriate data. A lot of appropriate here. In the form most convenient for the computation. The resulting pattern matching expressions enable data to be written in a convenient way that is very readable, greatly simplifying potentially complex branching and data analysis code. Okay. So I'm going to go back to the tour. So we went through this. Okay, optional types is next. Where was it? So active patterns are often used as views over data to make things more domainified. Okay. Copy that code. You'll see VS or code puts color on the type. So let's replace this. Yeah. So the type, system drawing color, which if we're already using system drawing, couldn't we just simplify that to just color? Okay, we can do that. All right, we still have that type of aliasing. Okay. So if I change the, if I made this just, right, if I did print all, purposely getting this to not match, right? Expression was expected to have type color, but has type string, yeah. Can I do that? Cool. Okay. I'm down with that. The type system can read your mind. Yeah. Figure the types in the reverse order. Start with what you eventually need and work back. The lack of defining types is hard for me to wrap my head around. It's, yeah, the fact that we're kind of inferring, right? Okay, well, call is of type color because we're passing it in here. Well, that's going to be an input argument. So it's effectively like doing this. You know, set it to the type that you think it is, but that's not real syntax, right? That's pseudo C#. Jeff made it up. You should see it says system drawing color. No, I'm not getting the right, it sees these. I'm not getting the IntelliSense. Yeah, and I'm not getting the hover. All right. All right, let's keep going along. Back to the tour. Optional types. One case of discriminated union types is an option type, which is useful that it's part of the F# core library. The option type is a type which represents one of two cases, a value or nothing at all. Okay. It is used in any scenario where a value may or may not result from a particular operation. This then forces you to account for both cases, making it a compiler time concern rather than a runtime concern. These are often used in APIs where null is used to represent nothing instead, thus eliminating the need to worry about null reference exception. Ah ha ha! We found you! Yeah, I'm not sure why it's not popping up here. If I look at the files, let's get rid of this. Yes, go away. I'm not sure. Include program FS. So it's there. Not sure. Got the book and we'll read for the next stream. I'm probably going to do the same. All right. So let's take a look. Let's learn about option values. First, define a zip code via single case discriminated union. Okay, so type zip code equals zip code of string. So here's, right, discriminated union, and we're aliasing zip code to string. Next, define a type where the zip code is optional. Customer with a customer record type with a zip code property that is of type zip code and it's optional. That's right. Okay. Would that be a frowned upon practice normally? Yeah, TLDR, I think that feels, while it's nice to have optional things like that, as somebody learning, it'd be nice to, well, I think we have seen it used frequently here. Next, define an interface type that represents an object to compute the shipping zone for the customer's zip code. Given implementations for the getState and getShippingZone abstract methods. So type iShippingCalculator abstract. Now, interface. It's interesting. We're saying this is an interface type. It's a type with abstract methods here. Where, right, is this an abstract class? Is this an interface? I tend to annotate most of my top-level functions. Yeah. In code reviews merge requests, you don't have hover tooltips. Yes. Alright, so iShippingCalculator has a getState method that takes in a zip code and yields a string that's option. Okay, I guess we'll see it down here. Abstract get shipping zone that takes in a string and yields an int. Okay. Calculate a shipping zone for a customer using a calculator instance. This uses combinators in the option module to allow a functional pipeline for transforming data with optionals. Okay, hang on. Customer shipping zone. And we're going to take in a calculator, which is of type shipping calculator, which has these two methods, and they take in a zip code and a string, Okay. And we're going to take into this method a customer object of type customer, which has a zip code. So customer.zipcode. So we're going to match on their zip code. Option.bind. Calculator.getState. Calculator.getState. So we're going to call calculator getState, and we're going to return a string. And we're going to bind it. So we're piping the zip code value into the option. We're going to take the zip code. And we're going to, which is zip code, which is optional. Think of it like this. If the state is not a proper state, we return none. Otherwise, we'll return some zip code. So this is effectively a nullable. So this might not always be able to get a valid result. There is no constructor on this type, so it's an interface. Ah, okay. Okay. That's okay. That makes sense to me. But all right. We know it's an interface and not an abstract class because it has an I at the beginning of the name. And our code would never lie to us. That's mean, Godfiend. But I like your convention. Oh, this is not a mix-up, but actually an interface in the example came out wrong somehow. All right. So so option is in my C# mind saying this is is saying that the zip code is, it's using the term optional, but to me as a C# developer, I'm seeing this like zip code question mark, right? It's a nullable object. It could be none, right? That none object in F#. So all right, get state zip code, and we're going to pipe it through, and it could be a string or none if it's not. Right? String option is the same as option of type string. Okay. So we're going to take their zip code, we're going to pipe it through option.bind. So if there was a value there, we're going to pass it into calculator.getState. Otherwise, we're going to return none. So we'll return a state: Ohio, Pennsylvania, California. And then we're going to take that value and pipe it through option.map. So if it is... Now, what's the difference between bind and map? We'll figure that out later. All right, but we're going to pipe it into the calculator get shipping zone if it is, right, if it is a string coming back. So get shipping zone will return an int. Okay. Try it with map in your REPL and see. Let's copy this. All right. I tell you what, I'm going to restart. I'm going to reload the window. Because I think Isaac's onto something there that I'm not getting the F-sharp interpreter loading properly here. And showing some of the hovers and all that feature, and still nothing. Yeah. All right. So if I run this, right, send the file to the... yeah, there's all my code. Okay. Module option values equals begin type, zip code, customer. Customer shipping zone, calculator, iShipping calculator, customer. So there's the, right, the two values that it's passing in. And it's going to return, it's going to yield an optional int. Okay. Map requires a valid value. Bind expects an option again. Bind calls an option. So string is not, right, is not optional here. Oh, TLDR, that's a lot of code. Option.bind. Yeah, I don't have a... I need to have the... Ooh! Stop moving. Stop moving. There we go. So Isaac gave us a gist. Let customer equals zip code string option. Let get state zip code. If zip code equals 90210, then some CA, California, else none. Let state equal get state 90211. Match state with none equals, oops. Some state equals printf. You're in the state of. Okay, so why do I need the keyword some if I am returning something? So I'm running into that. Oh, look. All right. So otherwise it's just a string. Really confusing example. Doesn't explain the option type. You need some because you're constructing a discriminated union of the option type. The return types have to match. Twitch borked my... Well, right, it's a chat room. It's not... So... Okay. Yeah, option bind is... These two are kind of confusing me here. Does this... Let's go through to that. Okay. When a search does not return a matching result, right, then it returns none. Okay. None is some. A static member that creates an option that has a value that is not none. Okay. Ignore option bind. You don't need it for a while. All right. All right. Then let's come back to that. I mean, I'm completely getting that we're right. This is saying, well, this is optional. This could be none, right? Which is effectively null. Not quite the same, but effectively. And we have a shipping calculator that is going to, the getState method, pass in a zip code and return some value coming out that's optional, right? And then get shipping zone makes sense. So customer shipping zone, we're going to take that customers, right? The customer has a zip code property on that record type. That zip code, we're going to take that value, pump it through here, and we're going to say calculator get state on that zip code, which will return a string, California, and then we'll take that and we'll call get shipping zone, which will return an integer. Makes sense. Okay. And we'll figure those out later. Units of measure. Customers.zip code is an option, and option bind takes that option, and if there is some value, it will then transform it into an option of the new type. Basically, option zip code to option of type string. Okay, then how's that different than option.map? That's what I'm trying to resolve here is what we've introduced new functions. What do they do? Right? I'm getting this is saying if this is something, take that as an input variable and pass it into this. The lambda in map doesn't return option. So map is saying if this has to be something, and pass it into this. Do you know the difference between .select and select many? You can set literal and other in F# is a nice way. All right, I'm going to go down to units of measure because I don't feel like I need these right now, and we're going around on these. Select equals map. Select many equals bind. Okay. Let's get back to that later. One unique feature of F#'s type system is the ability to provide context for numeric literals through units of measure. Makes sense. The units of measure allow you to associate a numeric type to a unit such as meters and have functions perform work on units. Okay. Meters, liters, feet, inches, pounds, grams. Yep. This enables the compiler to verify that the types of numeric literals passed in make sense under a certain context, thus eliminating runtime errors. Yes, a colleague of mine tried to do this with C# by actually creating classes that wrapped int, string, and boxing all of those things and unboxing them was you've created a class now that goes on the heap. You're garbage collecting value types. Ugh. Okay, units of measure. First, open a collection of common unit names. F# data unit systems SI unit names. Define a unitized constant. Sample value 1, 1600, and then I'm guessing, thinking of generic of type meter. There was measure top of type meter. The type definitions kind of remind me of Pascal types. Yes, that's exactly. The rest of it completely confusing me. Measures are still value types. Right. I feel like this is almost like that these measures are another discriminated union over those value types. Next, define a new unit type. Measure type mile equals static member as meter. Okay, so this is effectively a constant. And we're making this a measure. Okay. 1609.34 meters per mile. Define a unitized constant. Sample 2 equal 500 miles, like Indianapolis 500 race. Okay. So sample value 2 equals 500 unit miles, which are 1609.34 meters. Compute metric system constant. Let sample value 3 equal sample value 2. Hang on. All this sample value passing around. Let's see if... And I'm actually kind of getting here in right. So So sample value 1, got it, right? As meter, right? So we're redefining the mile with a conversion factor. Got it. Let's call this Indy 500, right? Because that's how long the race is. It's 500 miles. So we can call this the Indy 500 as meters. That makes a little bit more sense to me to follow these along. And this is Indy 500 times the mile type as meter. That's this conversion factor, which is, right, effectively it looks like a constant. But I think this is an interesting bit of notation to show this type of unit to that type of unit. 1,609 meters per 1 mile. The measure is erased at runtime. It's just there to compile check. Just like that type mile. That's pretty useful. Yeah. Yeah. You need to set type meter. Isn't meter coming in from unit names? Right, if I were to grab this whole thing. You know what? I'm not seeing the compiler at all here. I'm not seeing nothing. All right. So this is saying times that conversion factor. Cool. Okay, I get that. And then after a sample value 1, which was 1,600 meters, and then this I made Indy 500, and this is Indy as meters. I would walk 500 miles, which would be that number of meters. Clever. Just like the song. All right. The UOM stuff is pretty cool. Can you help me with the acronym? S&B? Unit of measure? Is that what that is? So it looks like meters provided in box, but not miles. I guess we don't like empirical units, but that makes sense there. Unit of measure stuff. Okay. All right, classes and interfaces. Here we go. This is, all right, I know what these are. F# has full support for .NET classes, interfaces, abstract classes, inheritance, etc., etc. Classes are types that represent .NET objects, which can have properties, methods, and events as its members. Right. Two-dimensional vector class, type vector D. A class's constructor is on the first line. It takes 2 arguments, dimension X and dimension Y, both of type double. Right, I'm assuming that's what the D is standing for. The internal field stores the length of the vector computed when the object is constructed. So let length equal squirt. Squirt? I'm guessing that's square root. The sum of the squares. All right. This specifies a name for the object's self-identifier. Huh? Right, just like we had before. In instance methods, it must appear before the member name. So member this.dx. So this we're defining a property. Okay. So and what I'm seeing is that these arguments are just they're just stashed in the class as properties, as fields, private fields that we can access throughout without seeing any problems here. At last, it looks a bit familiar. So we're exposing those as public properties here. This member is a method. The previous members were properties. Member this.scale k. So we're receiving some argument k, and we haven't specified what the type is. Vector 2D, right, which is a math method, which, okay, k times this.dx. So it's k is some sort of a numeric, and we're bouncing it off of those properties. This is how you instantiate the vector 2D class. Let vector 1 equal vector 2D 3.0, 4.0. No, wait, vector 2D is the name of our class. Hang on. So this method, it's scaling the vector by a constant k, right, and returning another vector object. Get a new scaled vector object without modifying the original. So we're taking vector 1, which is a vector 2D of 3 and 4, and we're going to scale it out 10 times. The length of vector 1, which is going to be 5. Length of vector 2 is going to be 50. Okay. Right, and vector 1 is 5, has a length of 5 because it's a 3, 4, 5 triangle, right? And if we scale it by 10, that goes to 30, that goes to 40, which is still a 3, 4, 5 triangle. 3 and 4 are the two legs of the triangle. The hypotenuse is 5, right? That's geometry, right? Our triangles typically are 3, 4, 5, 5, 12, 13. I forget what the third one is. 7, 12, 17 or something like that. I forget the third one. But those are the common ones that we see in math. And 3, 4, 5 is just really easy to remember. It's the typical one that you see for a right triangle, at least in samples. Let's see. Oh, we are almost out of time, and I am right at the end here. I'm going to finish this segment, and we'll start writing some sample code next time, I think. Defining generic classes is also very straightforward. Type state tracker of generic type T. Initial element is going to take in is of type generic type T. Okay. Let mutable states equal an array, a list, with that initial element in it. So we're passing one object into this. Okay. Pythagoras. Add a new element to the list of states. This dot update state, new state. Okay, so we're defining a method. We're receiving the new state. States, so we're taking that list and we're mutating the value by adding a new state. States, I'm not quite sure. Get the entire list of historical states. This dot history equals states. All right. Get the latest state. This dot current equals states dot head. I guess head is the first item because we're putting it at the front of the list. An int instance of the state tracker class. Note that the type parameter is inferred. Right, we see that in generic. Double colon prepends an item to a linked list. Ah. Okay, that makes sense. Note the apostrophe on the generic type. Once the type labels are working in ionide, you'll see that F# auto-generates generic functions all the time until the compiler infers it needs to be more specific. So let tracker equal state tracker 10. So it's going to initialize with 10. And then update state 17 will put a 17 in the front and push the 10 back. So, right, we would, we would prepend. I might be tempted to call this prepend, right? Prepend a new element to indicate and kind of show that it's prepending. So that makes sense. It's mutating the list, right? And it's a mutable collection because we've used the mutable keyword there. If we didn't, you wouldn't be able to change the states collection. Do you have Ionide installed on this PC? Isn't it the new one? Yes, this is the new one, and I do have Ionide. It's right there. Ionide F sharp. Just, oh no. Right? So it's here. It's installed. So. So this makes sense to me. as a object-oriented developer, I completely get this. Have I restarted VS Code? I did do the reload window. Not that one. This one. I need to be over here. Reload window. There is an output window for the F sharp compiler tools. I don't see anything. And no problems. It was working last stream. I'm not sure why it isn't this time. I mean, let's do a full close and reload. Still nothing. So, I've been using the F sharp, the Visual Studio F sharp REPL. It also works well. Yeah, I wanted to use Ionide here. Folks have had great success using Ionide. I wanted to give some props to the folks that worked on that tool. All right. So we did that one. To implement an interface, you can use either interface with syntax or an object expression. Type read file. This is a type that implements iDisposable. Let file equal new system.io stream reader. That makes sense. Member this.readline, file.readline. This is an implementation of iDisposable members. Interface iDisposable. So this is indented inside of this, and it's directly defining the members it implements right there. Okay. Let interface implementation equal new system iDisposable with member this.dispose. This is an object that implements iDisposable via an object expression. Unlike other languages such as C# or Java, a new type definition is not needed to implement. Right, so this is an anonymous type. And we're clearly... Okay. VS Code and Ionide is my favorite IDE experience. Out of everything I've used, bummer that the type interface labels aren't working for you. Yeah, I don't know. And I don't have, right? I mean, it's clearly detected. It's F sharp. Right, there's my project file. Not sure why it's not picking it up. Right, I've got this running. If I debug, so let's choose that one. No, doesn't like that either. Show the there it is. So and if I go over to my terminal, so I certainly have the F sharp tools installed. Right, if I do .NET new, I do get the F sharp templates here. So Not quite sure. The fact that stiff is filled in with the Project Explorer means that we can read it. That stuff. Ah, yes. And the icons. Yes, yes, yes. Right, when I click on here, it's not showing the... There we go. There's my code outline. So it's reading and interpreting the code, and I'm getting syntax highlighting, but it's not... The IntelliSense isn't landing for me here. Does the build from CLI have any noticeable outputs? Stand by. Hey, Bane Games. Build succeeded. So it works. Did I receive my affiliate email? Hey, it's Mike. I am an. I'm assuming you're referring to Twitch. I am a Twitch affiliate. So you should be able to scale and sometimes, occasionally, you should be able to scale and see different resolutions of the stream here. Was there? And now I have annotations? Not all of them. Right? There's well, okay. Yeah, it's come back. They just sent out emails saying sub badges are now a thing as well as quicker payouts. Do tell. Ooh, look at that. They did send out for affiliates. Nice. But it's Mike. I was under consideration for a Twitch partnership, and I was declined. I understand that they're not looking for creative streamers right now, but I'm not quite sure. Maybe missing .NET Restore was the problem. Could be. Could be. So I think recent versions have an implicit entry point added during compilation. Does anyone here know where I can ask questions on Windows subsystem for Linux? What kind of question do you have? I know a lot of creative streamers getting partnership quickly. Yeah, I'm not averaging over 75 yet. But I am one of the more watched developer streamers. Our friend Suze Hinton has 200 people watch her every Sunday morning. It's crazy how many JavaScript people tune in to watch. But .NET developers, we need to fill up here before we need to get more folks tuning in before we'll hit this. But Buoyant, what questions do you have about WSL? SSH agent processes are still persistent even after I close Bash. Oh, that's crazy. I don't know what to tell you about that. JC, I'm going to say, is that JC Marva? Merva? I'm not sure how you pronounce that. I'd like to buy a vowel. Welcome. Thank you for the follow. I appreciate you joining us. What was that question there? How similar is F# to other ML languages? What do you, ML, machine learning languages? What do you mean by ML? Tall pants. Which types to use? Blah, 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 blah. Discriminated unions have many uses, but the core benefit is to be able to utilize them in conjunction with pattern matching to account for all possible shapes that data can have. Classes are great for a huge number of reasons, such as when you need to represent information and also tie that information to functionality. Yes, as a rule of thumb, when you have functionality which is conceptually tied to some data, using classes and the principles of object-oriented programming is a big benefit. That makes sense. Classes are also preferred data type when interoperating with C# and Visual Basic. What might be a little confusing is we're using the term class to reference a type. right? Class is the term in C# and VB, but in F# we're using the term type, which I believe we also used for record types. So I'll get that down. Machine language, okay. ML family languages, OCaml, yep, there you go. Adaptive cards, adaptive tile stream coming. I think so, Janesco. Adaptive cards, yes. As I tweeted adaptive cards when adaptive cards was showed by Justin Liu. Meta language, okay. Yeah, so I reached out. I talked to the folks who run the adaptive cards project, and we're probably going to have them join us to show how we can use adaptive cards with some of our projects. But we are at 12:15, and we're through the tutorial here. So I've learned a bit here, right? I know where we can jump off. I know how to use some of these features. I think next week we can start tinkering with some very basic programs just to get our arms around some simple things here, and let's see what we can start doing. And then I think we want to do a little bit of F# programming with some Azure functions, and maybe see what we can do with that. So that's where I think we're going to go over the next few weeks here, and we'll adaptive cards with F#. That's an interesting idea. Maybe. I don't know. But I think content planning wise, I think next week we'll build some simple applications, little console applications, kind of like what we're seeing here with some of this, just to see how the pieces fit together. Go talk to Forky on Twitter about Azure Functions. Maybe we will. I don't know. I think there's opportunity here to do a lot of different things on our F# learning journey here. Adaptive cards with C# looked interesting during the Insider Dev Tour. Yeah, I think there's a couple things we can do there with them. But I'm going to wrap up here. So let's stop. I need to put a stop button over here somewhere. And let's wrap up. Thanks so much, everybody that joined us today. We had a lot of viewers tune in, a bunch of new followers. Thank you so much. I'll archive this video off. It'll be under the F#. I have an F# Fridays playlist on YouTube that you can check out, where I'll just keep adding these videos. So if you want to just learn F#, if you don't care about any of my other streams, you'll be able to follow along with the F# Fridays playlist over here on YouTube. So I'll archive off. It'll be over here in this playlist if you want to check out and see where we started and where we're going. It'll be over here. I hope you join me tomorrow. Tomorrow I'm going to go back and I'm working on a .NET command line tool, a global tool with a .NET command line that'll help us get samples, download samples from the web, and make it easy for us to put those down and run them right on our desktop instead of having to find them, do a web search, and go figure out, does this work with the tools that I have? I'm going to try and consolidate and make that real easy to do right from the command line. So, and I'm thinking on Tuesday, I have a couple guests that I'm interested in recruiting. If I do get one to join me on Tuesday, I'll announce and share that. Otherwise, I think I'm going to pick up where we left off with Amanda on Tuesday with Unity game programming and start building a pinball machine in Unity with C#. So maybe do a little bit more of Unit Tuesdays. So that's where I'm going. I'm glad you could join me. I hope you had fun. Thanks so much, everybody. And we'll see you next time. Take care. All right. Tomorrow, 10 a.m. Thanks.